I'm making this for you guys primarily for your trip to Chile, but hopefully you'll find it helpful, and we'll do a number of these the rest of the year. So if you'd like to follow along in the text, this is section 2.4 and 2.5. So we have finished at least we've had a quiz on the word problems and inequalities. And when I introduced these two sections, I did say that we would come back to these two uh, definitions and these two principles of conjunction and disjunction. And we are going to come back to it right now in using the definition and using the principle of absolute value. And you probably know, and hopefully it's not reviewed, that, and I've asked you in class, that if we say the absolute value of something and we use this, or we say the absolute value of b, or the absolute value of -2, what it's talking about is a distance from here to here that is b, or here to here, which is 2. Regardless, absolute value means the distance between one point and the next, and regardless if it's from here to here or here to here, it is the same value. Hence, absolute value. So in mathematics, we rarely do anything that doesn't have some function. So there is a function for this particular term, absolute value. Now, as I've said, the book always has some great, in my mind, some very good examples here. And if you follow along on page 73, there are a couple of examples. The first two are very important. This says, first one is solve the absolute value of 3x minus 2, close absolute value, equals 8. The second example is absolute value of 3 minus 2t, and absolute value is less than 5. Now, I'll drag you back and say, look, we talked about this concept of disjunction and conjunction, and I asked you to make a note of what these mean, and disjunction is a statement where we use or, and conjunction is where we use a statement that is and. How does this play into these two examples? This is example 1. This is example number 2. So how does this work? Well, if we go to solve this, what we're really saying here, see this expression, 3x minus 2 equals 8. If you think about it, what it means is that 3x minus 2 could equal 8. 3x minus 2 could also equal -8. And that is where we come up with an or. Because what is inside here could be negative, and we say that in this expression on the right-hand side, or this could be positive, which is this on the left-hand side. Now we solve this and we get 3x is equal to 10. Add 2 to both sides. X is equal to 10 over 3. We solve this on the other side. We get 3x is equal to -6. X is equal to -2. And this is or. Think about this again. Because this is an absolute value up here, way up here, because this is an absolute value, it means that this can be or. That it could be negative on the inside or positive, and we need to solve for each one of those. That's positive, that's negative. This equality becomes a disjunction. disjunction. Now, let's look at this other one. This is number 2. Look carefully, you'll see that this is an inequality. It's an inequality, not an equality. So how are we going to handle this? This means that 3 minus 2t could be less than 5. But it could also be, how do we use find the other side of that? Well, this on the right-hand side could be negative 5. Now, how we get this to be negative 5 is to multiply by a negative 1. When we do that, the signs flip. So 3t minus 2, which is here, becomes greater than a negative 5 over here. So now we have this expression, negative 5 is less than 3 minus 2t, which is less than 5. And this is a conjunction, because both things happen at the same time, therefore it is and, just like we did in the last section. Let's solve this side and solve it this side. We add negative 3 to both sides, we get negative 8 minus 2 is less than a negative 2t, which is less than, then negative 3 added to positive 5 is negative 2. Positive 2. Okay? Now divide by negative 2t. Now remember, we're going to divide here, so these signs, these alligators, are going to switch. Negative 8 divided by negative 2 is a positive 4. The sign changes. And we're left with t here. Negative 2, and this is going to switch. Positive 2 divided by a negative 2 is negative 1. Now there is a conjunction. So t at the same time is greater than 4 is greater than t, and at the same time t is greater than negative 1. Now, written in a solution set, if you'll look at the bottom of page 73, the solution set is t such that negative 1, and we're going to rewrite this, that negative 1 is less than t, which is less than 4, and close parentheses. Okay, now, once again, let me review this. Last time around, last section, we talked about disjunctions and conjunctions. A conjunction was and, disjunction, or. We're going to introduce in this section absolute value. How does that relate? Absolute value means the positive distance between 2 points. So we use 2 examples here. We use the absolute value with an equality, example 1, absolute value with an inequality, example 2. Now I'm going to pause this, and then I'm going to do section 2.5, where we're going to graph these, which may make a lot more sense to you. So let me pause this, clean the screen, and then we'll do the next section on graphing. So we can continue here with the next section, which is 2.5. Now 2.5 will probably help you guys a lot in understanding this, because 2.5 uses, excuse me, I need to get a pen here. I don't know what's going on here. Don't want that. Hang on a minute. Let me get a color. Sorry about that, guys. Here we go. So section 2.5 is a graphic representation. So what we're going to be doing here is on a number line trying to visually or graphically look at what the solution sets for these types of inequalities and absolute values are. So I think that much of this will make common sense to you. Now, please follow along on page 76 and 77 for the examples. Now, example 1 is, I think, pretty straightforward. They talk about finding the distance between the graphs of each pair of numbers, and it says 8, for example, and 17. So if we went, and this is 0, let's say this was 8, and this was 17. We find that distance by finding the difference between those two numbers. And we say that that is the absolute value of 17 minus 8. The absolute value, of course, of that is 9. Or if we had 8 minus 17, the absolute value of that would be the absolute value of negative 9, which is 9. So this is example number 1. So I think that that's relatively easy for you guys to figure out. So let's continue with example 2. So example 2 is, of course, a little bit different. This says, example number 2, that we have the absolute value of x minus 3 is equal to 2. So we want to try to find the graphic representation to that. Now the book does this differently than I do this. So I'm going to have you look at the book, and then you can listen and see how I do this, and you can choose which way is better for you. So the book says, look, start at 2 and start at 3 and let x equal 3, and when you find the difference of from x, it is 2. In other words, if we have 3 on the number line, and that is right there, and we go 2 either way here and 2 this way, then we find ourselves at 1 and at 2. Now, I do this a little differently and say, look, the absolute value of x minus 3 can be equal to 2, or it's a disjunction. It can be x minus 3 is equal to negative 2. If we solve this, we get x is equal to, if we add to both sides here, by the way, this is 5 up here and this is 1. The distance is 2 here. And if we solve this, then the answer is add both positive 3 to both sides, and we get positive 1. So both ways we end up with the same answer as the way the book does it. So now this is example number 3. This example is different because instead of an equality, we have the absolute value of y plus 2, absolute value, is less than or equal to 3. Now again, I encourage you to look at the way the book explains this. I'm going to do this similar way to section 2.4. I'm going to look at this inequality right here as a disjunction. Being the same thing, the very same thing, and I'm turning pages here. Excuse me, I said disjunction. This is a conjunction. Yikes, I'm really sorry. Conjunction. Wow, sorry about that. So I'm going to rewrite this and say that this is y plus 2 less than or equal to 3. Now, and, sorry about this, so let's make sure, stupid Randy, let's make sure that this is a conjunction. And remember I said that we need to find the other side of this. And if we multiply this by negative 3, then we get a negative 3 over here. And the sign would switch, which would be y plus 2 is greater than or equal to negative 3. Now here's the hard part. That would be y plus 2 greater than or equal to negative 3. this is the same thing as saying this, that negative 3 is less than or equal to y plus 2, correct? Now think about that for a little bit, and that's the hard part of this. Let me say it again. There are two options here. If this is the absolute value of y plus 2 less than or equal to 3, we can write this in two different ways. That y plus 2, of course, is less than or equal to 3, but what happens if what is inside here is less than or equal to negative 3? To make this negative 3, we multiply 3 by negative 1. It reverses this sign, which is over here. So y plus 2 becomes greater than negative 3. That is rewritten that negative 3 is less than y plus 2. Hopefully you can follow that. Now, this similar, we solve this here. Add negative 2 here, and we get negative 5, less than or equal to y. And we add negative 2, less than or equal to 1. Now, graphically, if you look at this on the top of page 77, then we have, as the book says, we have negative 2 here, and we go 3 here, 3 here, and if we do that, we'll come out with the same answers here, and we'll come out with negative 5 over here, and positive 1 over here. So now, what does this say? This says that y has to be greater than or equal to negative 5 and less than 1. So we can check this by seeing and taking any value in between here. So let's take y equals, let's say here, y equals negative 1. Does that work? Well, let's go here and say y plus 2, absolute value is less than 3. Y equals negative 1. So y is negative 1 plus 2. Is it less than or equal to 3? Well, y is negative 1, so negative 1 plus 2 is positive 2. The absolute, positive 1. Is the absolute value of positive 1 less than 3? Yes, it is. The answer checks. So listen, I hope this has been helpful. Please work diligently on these two sections while you're in Chile. And you can always email me with some questions, or if you want me to do some more problems. Have a great camp.